to our, I'm not sure what annual cool chemistry demonstration show is, and these balloons really do want to be together. My name is Dr. James Cabrel. I am one of the chemistry professors on campus. In fact, I am joined by three others, Dr. Carrie Rukamp, Bob Deckel, and Larry Bianconi. They have all helped out. They are all instructors for our chemistry courses, and all of their students are here helping out in some capacity today. So please give them all a round of applause for helping out today. As those of you that have gotten early, you can see that I tend to pace around like a tiger waiting for the show to start because I always get nervous, even though I'm up in front of students on a daily basis. This is a little bit different. So I'll step out from the balloons here for a second so you can see me better. So we will have some helpers today. So those of you that have been here before, we do a random draw. So I have two containers. One for younger kids, one for older kids. It will depend on the demonstration. We tend to keep the safer ones, safer demonstrations with the younger kids, the more dangerous ones for the older kids, although not too dangerous. The most dangerous ones, we don't let any kids up here except maybe these kids up here. So I will call one of the numbers, so make sure you have your tickets available. We'll make sure the lights are up when I say call for tickets. You'll come up to the far side of the stage. My organic students will help get gloves if necessary and goggles on, because you always have to have goggles on when you do scientific experiments. There are some at home that you can do without goggles that are pretty safe, but I would use them anyway. Some of the stuff that we are doing tonight will be a lot more dangerous than what you can do at home, so we want to be particularly careful. We have fire extinguishers, we have water, and we have some trained volunteer fire department folks on stage, so that always makes me feel a little bit better. So, after the show, when everything is done, you can proceed out of the theater and go in this direction around the building up to the science building, which is on that side. Go upstairs to the second floor, and everyone who's here will have a little activity. We can make some slime to take home with you. And there are also some posters that explain a lot of the chemistry that's going on, even though as the MC I will be explaining it also. So why don't we just get started? So the first demonstration is going to be the organic students, and they're going to be setting off these balloons. Though these balloons are not filled with air, as you will see. We will do them one at a time. After we do the first one, we'll do one to start off with, and then I'll talk a little bit more before you guys get too eager and set off the rest. This will be a little bit loud, so if you are sensitive to noises, I would suggest putting your fingers in your ears. Go for it. Lights down, please. Chase it, chase it. Okay. Okay. Hold on one second. Now, was that both? Was that with oxygen?
No. No.
Okay. So that was hydrogen gas. Hydrogen is very flammable, and what we mixed in was a little bit of salt to make the flame green. Normal hydrogen burns kind of a yellowish orange, and we made it green. That was copper. So now we'll do the next couple in sequence. So, lights down, please. That was red. Okay, keep going. The first few are filled with hydrogen. The next few are hydrogen and air. Are you awake yet? That one was just air. So, it's important to note that if you blow up a balloon with just your breath and you try to light it on fire, it will not light, which I think parents would be very happy about. Let's wait for this to clear a little bit. I think that was lithium. Lithium is white light. Okay, and now the last one. Thank you. Okay, so if you want to have a bit of fun with a bit of bang, mix a little bit of hydrogen and air. Hydrogen, when it reacts with air, makes water. So when those burst, they mix with water and they have the salt present and you get different colors. Now, where do you find different colors up in the sky? Fireworks. So the salts that were put into those balloons to make different colors are the same salts that they use to put in fireworks to get all the colors in fireworks. So it's the same kind of chemistry. Okay, now, Bill and Chi are next with a dry ice bubble. And we will need 2 volunteers from the smaller group. So make sure that you are looking at your tickets. I will pick one, I will mix, and I will pick another, just so I don't get the same 2 numbers. Okay, the first one is 703-891. 703-891. Please come down to the other side of the stage. The next one is 703-859. 703-859. So that side, the other side of where I am. That side. Do we get the first one? 703-891. Going once? Going twice? Okay. So again, every person that comes on stage needs goggles and in some cases gloves. We'll need gloves for this one. So if you're ever doing science experiments at home, you can always buy goggles and gloves at places like Menards or Lowe's. Okay. Please come up front and join Bill and Chi. You can stay right there. So, what's the magic stuff that was put in the water? Dry ice. Dry ice is not the same as normal water ice. It's made of carbon dioxide. Carbon dioxide, under normal conditions, is never a liquid. It goes right from a solid to a gas. So when you put it in water like this, it's instantly making a whole bunch of carbon dioxide gas. Now, you can buy dry ice at places like Miesfeld's, which I just learned recently. I'm from Manitowoc, so I never shopped around here. But I need... Oh, thanks. Hey, it's nice. But I like teaching here. So you could buy for about $2 a pound. Now, be very careful because it is very much colder than ice. You do not want to touch it with your bare hands. You could get frostbite very quickly. So what we're going to do is make some bubbles. So give it a shot. So you gently push the soapy towel over. You make a thin film of the bubble. Now go ahead and pop it. Go ahead and pop it. Now, we're using some special soap solution, more professional soap solution. If you ever see videos where they're blowing big bubbles, that's the stuff that we're using. This would still work if you use dish soap. You can have one of them do it if you want. It doesn't always work perfectly, but go up and poke it. Poke it. Poke it harder. Now, does one of you want to try it? You want to try using the towel? Go ahead. So this is technically speaking something that you can do at home. Oh, try it again. Go real slow. All you need is a bucket, dry ice, and some soap. And it takes a practice. Oh, oh. Try one more time. And you can make some really awesome bubbles. But again, you always want to be careful with dry ice. We'll try one more time and see if we can get it. If not, you can do it and get them to... Yeah, keep it real tight. That's all right. See, and if you put your hand in there right now, it would be way too cold. Push it right along the top, right over the top, right on the edge. Hey! Can I do it? Can I do it? All right. Thank you very much. You know what? We should just leave that running up here, just bubble. You can put it on the side here. It's fun. So if you ever see something like that in a movie or a TV show, the easiest way to do it is just a little bit of dry ice and water and let it go. Oh, does it on its own sometimes. All right, next we're going to have Derek and Preston with a flame test. And Walter the watermelon. We named him tonight. So, we're going to do two older kids this time. Yeah, move over to the center. Just put it right in the soap. Okay. 703-940. 703-940. 703-878. 703-878. So, last three digits, 878 and 940. I think we got one. Eight, 7, 8, and 940. Going once. Going twice. 931. 931. Last three digits, 931. Okay, we got one. I think actually we should turn it a little bit to the side. Like, not directly at the camera. Okay, so this takes the coloring for this particular test, which we would call the flame test, uses similar salts, some of them the same salts that we did with the balloons earlier, so you're going to see similar colors. Again, these colors are used to color fireworks. So when you look up at fireworks on 4th of July, think, that's a really interesting chemistry, which is true. So anytime you go to a fireworks factory, if they actually would let you in, they have chemists on staff that mix those fireworks together to get the best colors, the best spreads, the best displays. So we have spray bottles filled with a combination of water, alcohol, and the salt. Okay, first up, so 2 each. Lights down, please. You can get really close to it. So that is what white light. So that's lithium, right?
I'd tell you.
I tell you it's dark. Yeah, I believe that's lithium.
It's potassium.
Oh, it's potassium. Well, see, even chemists can be wrong sometimes. Lithium. Now it's red. Now that I think of it. Okay, we'll try the next one. So I think these students asked me for where they could find a pumpkin. And of course, this is definitely the wrong time of year to find a pumpkin. So I learned that you can carve a watermelon. And now you can spray it right through the flame.
All right.
Try the next one.
You want to spray?
I think Walter the watermelon's going to be a little toasty after this. Has anyone ever tried cooked watermelon? Try it one more time. Okay, 2 more. I believe that one's strontium. We had a guess? No. Try one more. The nice thing about the propane torches that we're using is they burn rather fast. All right. Thank you very much. I like it. Takes a bow. That's really good. That's really good craft. Okay. Now, Ian and Antonia are going to do Genie in the bottle. We need one helper for this. Okay. 703-935. 703-935. Last three digits. 935. Please come on down to the other side of the stage. Okay. So those of you of a certain age may have watched Bewitched, where there was actually a genie in a bottle. Some of you of a certain younger age may have watched the movie Aladdin, where it was Genie in a lamp. We don't have either of those kind of bottles. We are using special flasks that we have in the chemistry department called Florence flasks. And our helper is going to put in the special chemical, which is hydrogen peroxide. Now, some of you may have had hydrogen peroxide put on a cut or a burn. It is meant to kill bacteria and break down other organic components. But the hydrogen peroxide that you can buy over the counter is only 3%. So it is a very small amount of peroxide in a lot of water. This is 10 times more concentrated. So this is not something that you would want to get on your skin because it would burn quite a bit. So that's why we have gloves. But all you have to do is pour into the graduated cylinder. Now, hydrogen peroxide has a similar chemical structure to water. Water is two hydrogen atoms and an oxygen atom. Hydrogen peroxide contains an extra oxygen atom. And because of that structure, it breaks down very quickly. That's why hydrogen peroxide must be kept in brown bottles. So if you buy peroxide in the CVS or any other pharmacy, it will be in a brown bottle because light, normal light, can break down hydrogen peroxide. Now what we're going to do, and we're going to do this again in another experiment later on, is make that reaction go a lot faster. So we'll do this twice. Ready? So this is what happens when you release all of that oxygen all at once. Unfortunately, we don't get any wishes. If I did, I would wish for this weather to continue. Those of you that may have been here last year, there she is. And there's the other one. And this is not the smoke that comes out from doing the flame test. This is simply oxygen and water. So that's Genie in a bottle. Okay, Jason, Andrea, and Sam. This is chlorine pop, and this is dangerous enough that we're not going to have any helpers this time. And we're going to have a little plexiglass shield. This is a new experiment to me. They found this one and showed me, and I said, okay. And then they practiced the other day, and I said, oh, okay.
Yeah, that's another bottle.
Big tray.
This one?
That one. Okay, we need that.
So, there's an interesting combination of chemicals here. The first chemical that they are going to put into a test tube is sodium chlorite. So, chlorite is chlorine with two oxygen atoms. It's related to hypochlorite, which is bleach. So it contains chlorine and oxygen. What they're going to add in is an acid called hydrochloric acid. And what you may hear, depending on how this works, is a little bit of a pop. When you mix chlorite and HCl acid, you make ClO2 gas, which is yellow. And it's a very reactive gas. So let's see if we can get this to work first. Just go ahead and add it in. Nope, no popping. I was wrong. So that's how vigorous a reaction can be just from HCl. So that's not even the best part of the experiment yet. That's just the formation of the yellow gas. Oh, they want more, they say. It's not always a good thing when students tell you they want more of something when it comes to a chemical demonstration like this. Okay, maybe that was a little too much. I think it'll be good. Okay, so now we're going to react with nitrites. And it's going to oxidize the nitrite to nitrates. And Jason's waiting for enough gas because Jason always says that it needs to be filled with gas. This could be loud. This is why they have a couple of test tubes. Okay, we'll try it one more time. We did. Ooh, I can smell the chlorine. We did this in the lab the other day, and it was a bang, not a pop. So when I said, maybe I should have said chlorine bang on the list instead of chlorine pop. So we're gonna. Well, that's at least loud.
Oh, I can smell it.
Okay, so it didn't. Don't worry, they showed me a video of a professor at another university doing this, and he was holding it in his hand. And they said, well, do you want to hold it in your hand? And I said, no. Just a little bit.
It works perfectly in class.
Yes, well, things always work perfectly in the lab, and not when you're under pressure. It's not supposed to be doing this. That's never a thing you want to hear from a chemistry professor, by the way. This is why we have the blast shield. All right.
We got popping.
No, that'll be done. Okay, you can take that one outside, actually. Take it out the back. I'm sorry. Not everything works. One demonstration every year just doesn't want to do exactly what it wants. But it was a good try. Okay. So next is the organic students are going to come back and they're going to do magic styrofoam. So we need one helper for this of the younger crowd. Don't worry, the older ones will get you. Okay. 703-883. 703-883. Last three digits, 883. All right, we got one. Yippee-ki-yay. That's what I would say. I would like to say that my son is in the audience. He's only 2. But this isn't his first cool chemistry show. He went to the one in Manitowoc last year. So I will give a plug for my wife. She runs the Cool Chemistry Show in Manitowoc. It's in 2 weeks on the 29th on the UW Manitowoc campus at 6:30. This is where you get to have fun and actually tear the styrofoam, which might be the most fun out of this. That's plenty. That's plenty. Okay, so what we're going to do is we're going to make the styrofoam disappear. So, Styrofoam is made of a polymer called polystyrene. And if you want to know how versatile polystyrene is, the same polymer is used in plastic utensils. Looks a lot different, doesn't it? When polystyrene is processed, it's processed in such a way that there is a lot of air put into the polymer, which is why it's so light. So, go ahead and put it in there and see what happens. That is a good question. Where did it go?
Oh my God.
Just push it down in there. Make it all disappear. By the way, this is not the way that you want to recycle polystyrene. So what we're doing isn't really magic. The liquid is acetone, which is the biggest component in nail polish remover. So it's a good solvent. And what it's doing is changing the structure of the polystyrene just enough to release all the air. And so what's left is simply the polystyrene polymer as a goo, which I'm going to eventually have to clean up, in the container. I don't think we need to do the whole thing, although that would be fun. Again, this is something you could try at home. The reason why I wouldn't suggest it is that whatever container you do this in, it's going to be ruined. So we have an old baking dish that cost about 99 cents. Okay. Okay. Adi and Armin are next. They're going to do a whoosher bottle. This is one of my favorites. And so they're going to do this a couple of times. No help on this one because it's a little too much of a flash and a bang. Besides, this is better viewed from afar. I told my students that I would talk myself hoarse by halfway through the show. It's true. If it's one thing a professor can do, it's talk. So what they're going to be doing is they're going to be filling these bottles with different alcohols, and in one case a mixture of an alcohol and borax. When you light something, when you ignite something in a bottle like this, all the heat and flame wants to rush out, and so it rushes out all at once, but the air has to be displaced. So you end up getting a loud noise. We'll wait till you're ready. What's the first one? Ethanol is the first one. Yeah, you got to turn it from. Here. Do you? Lights, please. All right, we'll do two more. This one, I believe, is 1 propanol. Now, you can do this with methanol, which is a smaller alcohol, but it actually happens so fast and so loud that it's not worth doing, in my opinion. You can also do this with rubbing alcohol, which is isopropanol, and it goes too slow and it's kind of boring. So we're using the ones that are sort of halfway in between. I get to use the torch. That's the fun part. Okay. Lights, please. Yeah, I like that one. And so the last one is a mixture of alcohol and borax. Now, if you remember the colors that we had from the flame test, One of the colors was green, and that was copper salt. You can also get green from boron, and borax, which is a detergent, contains the boron atom, which will glow green when you burn it. And I think I just heard my son in the back of the audience. That's so nice. In a couple of years, I'll get him up here, if he's lucky enough to get the right ticket. Lights, please. Awesome. Well done. Okay, thank you very much. Okay, like a podium. This is also one of my favorites. And some of these students took the old adage of go big or go home to heart with this one. So we need two helpers for this one. The first one is 703-863. 703-863. So 863, please come on down to the exit sign. 703-873. 863 and 873.
Hopefully this one will get.
You know it's going to be a good time when they bring out the air compressor. So, for this experiment, we're going to do this a couple of different ways. We're going to save the air compressor for last. Good. So, what we're going to be using in this experiment is Lycopodium. Lycopodium is a moss. When you dry the spores of the moss, and you have cornstarch in there? You can also use cornstarch. So when you dry the spores of the moss, you get a very, very fine powder. We're going to use this with cornstarch also. So if you try to light this on fire, if you try to light this on fire, it does spark a little bit, and it certainly does burn a little bit, but it instantly goes out. What we need to do is disperse it. Oh, you got it. So you could do this with cornstarch or flour. Did you guys try flour?
Powdered sugar.
Powdered sugar? Didn't work? Okay. Now, yeah. We're gonna add some juice. So lights, please. So we're using an air compressor to blow through the flame. Maybe. The lights back on, please. We're having some technical difficulties.
It turned on.
Can I try this one? Lights, please. There we go. Go. Give our other helper a shot. There we go. All right. Thank you very much. I can't say I ever thought of an air compressor before for that experiment, but maybe I don't go big or go home enough. Okay. Next is the organic students coming back with fog cans. Do you guys have the cups? Okay. So, 2 helpers for this one. (703-869) 869 and 703-844. 869 and 844. Someone help with goggles, and just need goggles, no gloves this time. Can I have a cup?
Yeah, the cups are Jacob.
So, we have these special awesome contraptions, and they are filled with fog from a fog machine. Let's wait until we get our helpers up here and give them a cup. I hope your aim is good. So we're gonna do a little. Really? I think someone's doing chemistry experiments outside the theater.
Can you just show them what it is about first?
So we're gonna do a little William Tell. So go ahead and show. Hey. So now our helpers can come up. So all you're doing is you cut a hole in the bottom of a trash can, 55 or 20 gallon trash can.
You go behind the back of the trash can. There you go. And now we're gonna hit it real hard.
There we go. Hey! And so this makes a vortex of air. So even if we didn't use the fog, this would still work. The fog just makes it visible. Come on. Oh, right in the face. Hey! So these are very easily made at home. In fact, if you go to most science demo websites, they'll be able to. I like it. Yeah. So if you want to make these, the one thing you need on this end, the drum end, this is a shower curtain. And very cheap, clear shower curtain, so a couple of bucks. So with the trash can, a little bit of cardboard, and the shower curtain, and a little bungee cord, you're going to have a great old time. Now, if you don't want to buy a fog machine, use some dry ice. Dry ice and water. If you get the vapor up in here, it's not that easy to do, but you can do it, and you can have your own fog guns or fog cans. If we had time, we'd give everyone in the audience a cup, but unfortunately we don't have time. So thank you very much, our helpers. Okay. James and New, we have lava lamps next. So again, we need 2 younger members. And yeah. And this is one you can do at home. So parents, pay attention. 703-892-892 and 703-865. 892 and 865. Please come on down. 892 and 865. We got 1. And we got 2. So this is a particular experiment, if you will, that you can keep and reuse over and over again. So what you need is a few empty soda cans of variety of sizes. You could do 1 liter, you could do 2 liter. Some vegetable oil, food coloring, and some Alka-Seltzer tablets. So we're going to make one, and then we're going to use the rest and have a little display. So all you really need to do is put the oil and water in any order. Now, water and oil do not mix. Oil is nonpolar, just like fats are nonpolar, and water is polar. And polar things do not dissolve in nonpolar things, and vice versa. So you can pick your favorite color. In addition, if you want to make these glow in the dark and you have a black light, you can use highlighter fluid. Unfortunately, the only way to get highlighter fluid is to actually pull the tip out and drain the liquid, but you can do that if you're careful and if your parents let you. But you can get a variety of different glow-in-the-dark colors that way. And it really doesn't matter how much of each that you use. So you can fill it up all the way with oil and just a little bit of water. And this is why we have rubber matting on the stage. Oh, we're leaking out. That's okay. It's just vegetable oil, fortunately. So now, when you have your lava lamp set up, all you need to do is drop in an Alka-Seltzer tablet. You might have to break them up, but all you need to do is drop them in. The two reagents within the Alka-Seltzer tablets make gas, carbon dioxide gas. And it simply bubbles out. The water is less dense, so it is on the bottom. And it reacts with the Alka-Seltzer, and you see it bubbling up through the oil. It looks like the thinner ones are working a lot better. I wonder why that is. So you can keep this going for a while, impress your friends. And the nice thing is that once the chemical reaction is finished and you're no longer making bubbles, you can seal this up and store it and use it over and over again. Until at some time that the oil eventually goes rancid. But that usually takes a few years. Now, one thing you don't want to do with these lava lamps is to seal them while the reaction is going. Because you build up gas, and if you build up gas in a plastic bottle, bad things typically happen. Now, if you're shaking up a soda bottle and you have all that pressure of carbon dioxide, they'll withstand it. But if you build it up a little bit too much, well, you don't want that to happen with a lot of oil and water everywhere in food coloring. So, something you could very easily do at home. All right, thank you. We'll just put these aside, caps off. We'll put them over here. Okay. Our partners in crime, Jason, Andrea, and Sam. This is Methane Bubbles, and I get to be involved in this one.
I got the gas going outside.
Okay.
I don't know how to get the bubbles so I can bubble in with the tube.
Okay, so what we have in this inner tube is not air. It's natural gas. So we have natural gas piped through. Someone can get me the candles, the yardstick candles. Where are those?
Just here.
Yeah, give me one of those.
Here, can you?
So what we're going to do is make bubbles filled with natural gas. And you say, why would you do something like that? Because we can. Now, I would get higher than that. Okay.
Wait,
Yeah. So what these students are going to do, bravely do, is take some of these bubbles in their hands. Whoa, what are you trying to do to me? And I'm going to light them on fire.
One more time.
Push hard.
I'm pushing as hard as I can. Again with the go big or go home. Okay. Lights. Ah.
You died.
I'm sorry, I'll go faster. You want to try it one more time? So, one of the nice things about these methane bubbles is that they burn so quickly. As long as you have your hands covered in water, your hands are protected. I tend to do this one every year, but I took the back seat this year. I'm just making the bubbles. I'm not...
Oh, we can light you on fire.
No, it's okay. I don't think I need to be lit on fire this year. Okay, thank you very much. It's amazing what you could do with a propane torch. So those of you enterprising parents that, want to do some interesting experiments at home, please be safe.
Want to retry that one or not?
No. Okay, so Courtney and Crystal are next. Oh, sorry, Joe and Blake are next. Whoops. They look at me like, no, not yet, not yet. Okay, 2 more helpers for Elephant's toothpaste. Are you guys going to do 2 of them? Or are you doing 1? You're just going to do 1? Okay, 1 helper. Okay, 703-872. 703-872. You can do 2 helpers? Okay, we'll do 2 helpers. Okay. 703-872 and 703-894. So 872 and 894. Yes, make sure you get your goggles on. I think actually we'll do this on there. Since it's likely going to stain. Now, we've already had some fun with hydrogen peroxide. We're going to have a little bit more fun with hydrogen peroxide. I thought I saw 2. 894 and 872. We got 1. Last chance. I think since we're ready, we'll just go with 1. So, we're going to mix a couple of chemicals, and again, we're using soap and we're using food coloring. And so what we're going to do is use a catalyst this time, much like we did with the Genie in the bottle, although it's going to be a different catalyst. And when we create the oxygen this time, it's going to create a lot of bubbles. So this is one of those where you pour it in and you step back. Ready?
Pour nice and quick.
Let's pour it all in at once. Yeah, it's hot. Well, I can say that I've never had one go off that fast. Now, this is just very warm soap at the moment. And it's still going, so... Unfortunately, a lot of it... Here, I'll move this around. I apologize about the shirt. I'm willing to pay for it. It should wash out. Very good, thank you. can't wait to, I missed it. I can't wait to see that one on video. Okay, now we can do the Screaming Gummy Bear. No, we can do it. Let me just move the suds out of the way. And what did I forget? I forgot the kiddie pool. Oh no, it smells dawn fresh. It's just multicolored soap. Okay, so if you ever wondered how much energy you can get out of a single gummy bear, we're going to show you. And frankly, we're going to show you with a peanut M&M too. So, by the way, I've learned recently that the whole idea of sugar making kids hyperactive is a myth. I don't know if I believe it because I have a 2-year-old. But we're going to show you how much energy that you can get out of a single gummy bear. So what we need to do is heat a very special chemical called potassium chlorate. So it's another reagent that has chlorine and oxygen. And we're going to use that oxygen in order to react all of the sugar in a very short time. Yeah, so typically when you run a reaction, you run it in a solution of some kind, but this time we actually have to melt the potassium chlorate. And it does take a little bit of time. The whole, like all the stuff that I had in here, including the trash bags, is all covered in soap. It's rather hilarious. It's almost done. So when this is ready, we're going to drop a gummy bear right down in there. And you'll see what happens. And then we're going to do an M&M. Are you doing an M&M both times then?
What?
Which one? Gummy bear first? Okay. All right, looks like it's ready. Lights, please. Oops. It's right there. It's right there. Lights again. So this is how much energy that you can get from a single gummy bear. Imagine a handful. Now, so we're going to do one more. We're going to do a peanut M&M. Is it that hot? Maybe. You could just... Yeah. So this time we're going to do a peanut M&M. Okay. I'll do it because I need to have some fun. And I'm talking. So the difference between a gummy bear, which is just pure sugar, and peanut M&M, you have fats in the chocolate, and you also have the peanut, which contains a lot of protein. This is the fun part. Just using fire. I know everyone gets to the chem labs, and when I talk about doing this demonstration show, they ask me, "Can I blow something up?" And then they're shocked when I say, "Absolutely." But don't be surprised, kids, if you ask your parents. You say you want to blow something up and they say no, don't be surprised. All right, you can get it ready. We're almost done. So there should be more energy from the M&M because there is more energy locked away in the protein than there is in pure sugar. I thought it was almost ready. Okay. Okay, Okay. Now it's still burning away all the sugar, the candy coating. But notice how it's sparking coming out. That's reached the, whoa, it's hard to look at. That's the protein at the end. All right.
I'll clean up this mess.
Okay. No, I'm not going to eat it. Are you crazy? Okay. So, our final demonstration, the big finale, is the organic students, and it's magnesium and dry ice. So we're actually going to move this back. There should be one over there. Because this one is a good light show. Could someone help me move this table out of the way? I'm going to move it over here. Okay. Oh man, that smells like burnt candy. Okay, so most things burn in air, burn with oxygen. So when you burn something, you combine a fuel and an oxidant, and that's typically oxygen. But you can actually burn things whoops. You can actually burn things in an atmosphere of carbon dioxide, and magnesium will do that. So what the students have done is they've taken a block of dry ice, they've made a hole in it, and what they're going to put in is magnesium. Magnesium also reacts with oxygen in the air. This magnesium actually has a fine coating of magnesium oxide. But what we're going to do is burn that away, and the pure magnesium is going to react with dry ice. Now, it won't go just the magnesium and carbon dioxide together until we ignite the magnesium. So do I get the honors? I'm the propane torch man tonight. So get ready to step back. Go. So magnesium does burn very, very bright. In fact, it can burn so bright that it's too hard to look at. That's why we're lucky to have the dry ice here. Otherwise, without the dry ice there, you would not be able to look at that reaction. And it's still going. And it's got this nice, lovely glow. And I probably shouldn't go too close to it at this point. But what happens, what's left over, is magnesium oxide and carbon. So what will be left in the center here is simply a lump of carbon. Lights, please. You want to take the top off? It's just ash right now, and I wish it was a better lump, but it's just ash, just carbon. So, that's it. You can put the dry ice down. Okay, that is our list of demos for this evening. Thank you very much for coming. Just remember, always be safe when you're doing chemistry, when you're doing science at home. Always have parents' permission and parents' observation.